Okay, ladies and gentlemen, I'm not going to be able to come in today, so I'm going to have to deliver this lecture here, and you can watch the video. Your warm-up was to analyze and graph two trig functions, and we're going to go over them right now. So, the amplitude is always the absolute value of the coefficient of your sine or cosine. So here, this is secretly a -1. The absolute value of -1 is 1. So that negative is not stretching or shrinking anything. However, that negative is causing it to reflect across the x-axis. The period of sine is normally 2 pi. However, this 2 right here is causing a horizontal compression by a factor of 2. In other words, to find my new period, I need to take that 2 and put it under 2 pi, and lo and behold, the period of this transformed function is pi. Plus 1 is my vertical translation, and the only one left is phase shift, which is kind of the pain in the butt of the entire family. In order to find the phase shift, you need to take that coefficient of x and you need to factor it out. And now this number is your phase shift. Remember that stuff that affects the x values always is backwards of what you would expect. So if we have x plus pi inside our function, that means that we're going to move left pi. And you can write that as left pi, or you can write that as negative pi. Okay, so I'm going to put this all together and I am going to graph this. So first I'm going to start with regular old sine. Sine of 0 is 0, and then it goes and does a little bit of wiggling so that it looks like wee. Then we can go backwards. Wee. So like that, except, you know, smooth and awesome. Okay. So there are several things happening with this function. Our amplitude is 1, so that didn't change, but I need to reflect across the x-axis. So I'm just going to reflect all these points across the x-axis. Okay, next up, I think I'll do light blue. Okay, I need to do a vertical transformation. Well, no, sorry. Next up, I'll do the phase shift. Holy, what is wrong with me? What is wrong with me is it's 2 in the morning. Let me try that again. We do all our stretching, shrinking, and reflecting first, so next up is to change the period. Normally, the period is 2 pi. It takes an entire 2 pi to do one whole wiggle, but we're going to compress that to just pi. So I have to do a whole wiggle in just pi, which means that all of this is going to happen much more quickly. Let's see. So I'm going to bottom, top, B, one wiggle, and then another wiggle, and I can go backwards. A wiggle, and a wiggle, and a wiggle, and a wiggle, and a wiggle. Okay. That's the new period and the reflection. Now I'm going to do the phase shift and the vertical translation, all kind of in one fell swoop. So the phase shift has me scooting everything that way pi, and you'll notice that from here to here is pi, and there, and there, and there. So I'm scooting everything over one whole pi, and I'm going up by 1. Well, let's see. If I scoot things over one whole pi, I notice that nothing changes. Like this dot scoots This dot can scoot over 1 whole pi. Oh, now it's here. Oh, but that was already a maximum. This minimum can scoot over 1 whole pi. Oh, well, now we're at this minimum. So my phase shift is actually not really changing anything. You can scoot it over, but you end up with something that looks identical to what you already had. So really all I need to worry about is a vertical translation of up 1. So I'm just going to take all of these lovely dots and scoot them up 1. So that my new center line is here at y equals 1. I'm drawing a whole bunch of purple dots that make it kind of look like a zigzag, but we know better. It's not a zigzag, it's a lovely sine curve. And then when you connect the dots with a lovely wiggle, you will know the truth. Wiggle! Okay, so this is one way of graphing transformations of trig functions, is start with your original function, then start doing the transformations, beginning with reflections and dilations, then doing translations, which would be the phase shift and the vertical translation. Okay, let's see. Y equals 2 cos of 1/2 x plus pi, all minus 1. My amplitude is the number out in front, well, the absolute value thereof, so 2. There's no reflection because neither cosine nor x are negative. The period is 2 pi divided by the coefficient of x. So that's 2 pi divided by 1/2. Dividing by 1/2 is the same as multiplying by 2, so our new period is 4 pi. Our vertical translation is down 1 or negative 1. And the last thing we've got to do is phase shift. Phase shift is a pain, so factor out that 1/2 and we have x plus 2 pi. So that means that our phase shift is left 2 pi or negative 2 pi. So if I wanted to graph the cosine, assuming each of these vertical tick marks is 1, it would go 1, and then at 2 pi back up to 1, which means there, there, there. Wiggle. Okay. So I'm going to draw a bunch of pastel in-between things. Amplitude of 2, so I'm going to double the y value of all of these points, which doesn't really affect something whose y value is 0, but makes everything that's not 0 a lot twice as tall. Okay. It's not reflected. The period is now 4 pi. Holy moly. Okay, so what I just basically have to do is stretch it horizontally so it's twice as big. In other words, every single point gets an x-coordinate that's twice as large. So let's see. This point is now going to be over at pi. And where I was at pi, I'm going to be at 2 pi. And now I'm off my graph, so I'll go backwards. This point is now going to be at pi. This point is now going to be at negative 2 pi. Alright, so wiggle, wiggle. Then I have to do my translations. I have a phase shift going to the left 2 pi. So let's see, left 2 pi. So this would be over here. Oh, interesting. This would be 1, 2 over there. And this goes over there. And so my new function goes like that. which looks a lot like it would like a reflection of cosine. And then last but not least, I've got to go down one whole space. So my new center line is there. And my graph now looks like that. And if you focus on the black graph, which is cosine of x, and the purple graph, which is 2 times the cosine of 1/2 x plus pi, all minus 1, you can kind of compare them. And the little pastel things in between are the in-between steps. Today we're going to be working on a worksheet that hopefully your sub is able to pass out to you. So what's really more common on the IB exam, rather than graphing things by hand, they don't do that very much. Often they will have you determine the equation of a trig function either from a description or from a graph. So that's much more common. So we are going to come up with lovely equations. Determine the equation of a sine function with maximum value 10, minimum value 4, period pi over 2, and phase shift negative pi over 6. So I can fill in some of this. Pi over 2, negative pi over 6. Okay, let's see. It says nothing about a reflection, so I'm going to assume that there is none. So I just have to figure out my amplitude and my vertical translation. Let's see, there are a couple ways I can think of this. I can think, okay, my maximum value is 10 and my minimum value is 4. The distance between 10 and 4 is 6. And half of 6 is 3. So we've got 3 and 3. And remember that amplitude is the distance from that center line to your extreme values. So my amplitude is 3. Another thing you can do, well, and then you can say, oh, let's see, if we start at 4 and we go up 3, that means that this center line is 7. The other thing you can do is the midpoint formula, basically. 10 plus 4 divided by 2. It's kind of like the average of the two. So that'd be 14 over 2, which is in fact 7. Okay, that means normally the center line of the sine function is at y equals 0, but now apparently our center line is up at 7. So that means we've been shifted up 7 units. Okay, so let's see. Because I have a phase shift, I'm going to go ahead and write this in the form a sine of b x plus c plus d, where I've got my coefficient of x already factored out. So that means I can just plug my phase shift in. If I want to go, if my phase shift is negative pi over 6, that means I'm going to the left, which means I need to add pi over 6. So I've got x plus pi over 6. Amplitude would be a, so 3 times the sine of blah, 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 plus, and my vertical translation up 7. So the only part that's a little tricky in here now is getting the period to tell me what b is. So remember that you take the original period, which is 2 pi, and because we're talking about x and it's crazy, you divide by that coefficient, and you get your new period, which in this case is pi over 2. So you could do, I don't know, a little bit of cross-multiplying foo, and you will get 4 pi equals b pi, and that means that b is equal to 4. And this is just one of like a zillion, infinitely many equations that would make the same graph. Now we're going to determine the equation of a cosine function. Oh boy, they gave us specific points. Let's see if I can graph this. So we've got pi and 3 pi. So I'm going to put my axis over here. 1, 2, 3 pi. 3 pi, 10. Okay, and pi, -4. Well, -4 is not as big as 10, so down there. Now I'm going to make the assumption that there is not some, like a whole bunch of wiggles in between there. That might be true, but I'm going to just assume it does something like and smoothly connects, and it's just half of a cycle from those 2 points. So let's see, if half of a cycle takes 2 pi to do, if I go backwards here, 1, 2, so that I'm now at -pi, I should be back up at 10. Let's see, so to go from 10 to -4, the center line must now be at 3. That's sort of 3-ish. So that tells me where to draw those dots. Okay. So this is my fabulous picture. So let's see, I can say that the amplitude, well, 3 to 10, that would be 7. And let's see, my period is 4 pi. A cosine function. Okay, let's see. Well, let's talk about our vertical transformation. Since our new center line is at y equals 3, I know that I've gone up 3. Here's the thing, there are infinitely many cosine functions that would make this graph. So I'm just going to pick one, maybe 2 of them. So one thing I can say is that maybe this cool spirally point used to be over here, and this is just a phase shift from 0 to -pi. So that would be a phase shift of -pi. So in that case, my function would be 7 times the cosine of 1/2 of, and the reason I got 1/2 is that I know 2 pi, that's the normal period, divided by whatever that number is, has to give me my new period, which is 4 pi. So that's how I know that it's 1/2. X, and let's see, to shift to the left pi, I must have plus pi. And to shift up 3, I have plus 3. So there's one equation that describes that. Now, instead of having a phase shift of -pi, maybe I flipped it vertically and then I scooted that way pi. So then I would have y equals -7 to get that vertical flip. Cosine of the period still the same, so 1/2 x. Whoops, my phase shift is different. My vertical shift is still the same. Okay, in order to scoot to the right pi, I must have minus pi. And if you graph these 2 equations on your graphing calculator, making sure that you're in radian mode, because we're using radians to describe our angles, you will get the exact same line. We can actually, just for giggles, do this, but instead make a sine function. So if we want a sine function, sine normally when x equals 0, y equals 0, and it's doing something kind of like that. Kind of like y equals x, and then it does some wiggly poos. So in order to make it look like this, I either have to reflect it or horizontally translate it, phase shift it. So I'm going to do both just for giggles, but let me go ahead and write out some stuff. So my amplitude is still, what is my amplitude? I don't know, I forget. My amplitude's 7. My period is still 4 pi. And my vertical shift is still up 3. So if I reflect this, I don't need to do any phase shifting at all. So I'm going to have 7 sine, maybe I'm going to have a sine, and reflecting means I need to make it negative 7 sine of 1/2, b is still the same number, of x. I don't have a phase shift at all, so I'm done with that, plus 3. So that's one possible equation. Or maybe instead of reflecting it, I just translated it, this point, all the way over there, which would be, oh boy, plus 2 pi. So y equals positive 7, because this time I'm imagining that I didn't flip it, I scooted it, times the sine of 1/2. Since I do have a phase shift this time, I'm going to go ahead and factor that out. And I said that I scooted to the right 2 pi, so that's minus 2 pi. Plus 3. Oops. And these are exactly the same graph, but two different ways of plotting it, or describing it. Oh boy, this totally looks like something you might see, if you're very lucky, you might see on an IB exam. So let's see. The first thing to do with these is just go ahead and with your eyeballs find the center line and draw it in. Once you've got your center line, you can immediately say how it's been vertically translated. It went from wiggling around the x-axis to down here at y equals -3. So it's gone down 3. Oops. The other thing that that center line makes really easy is figuring out your amplitude. From the center line, you go up 2 spaces, so our amplitude is 2. Let's see, to get the period, you just have to get one whole wiggle, and you can do that from any, you can do it on any part of the graph. It's often easiest to go like peak to peak or valley to valley. So I think that's what I'm going to do. So if here's a peak, there's another peak. And it looks like, where is this? If this is pi over 2, and it's cut into thirds, a third of pi over 2 is pi over 6. We've got pi over 6, 2 pi over 6, 3 pi over 6, and yes, I know these reduce, right? So we go 1, 2, 3, 4 of these pi over 6. So our period is 4 pi over 6, which reduces to 2 pi over 3. Okay. We're supposed to do a sine function here, which is really convenient because remember, sine starts at 0, 0, does something like y equals x, and proceeds to wiggle on its merry way. And this function, if we ignore the fact that it's scooted down, starts at 0, 0, and has a positive slope right there. So we're ready to just, we don't have to do any phase shift. Lovely. Okay, so our sine function is going to be 2 times the sine. Oh boy. Well, 2 pi over b is supposed to equal our new period, which is 2 pi over 3, which kind of tells me that b must equal 3. So 3, I don't have a phase shift, so I'm not going to bother to factor out my coefficient. So x plus nothing, and then it's shifted down 3. So y equals 2 times the sine of 3x minus 3. Now we've got a cosine. Let's see, I can't really go peak to peak because I only have one peak, but I've got a couple valleys. So here's the bottom of one valley, there's the bottom of the other valley. Let's see, negative 2 pi to 0 is 2 pi long, and then I've got another 2 pi, so this period is 4 pi. Oh dear, but that line I just drew, that's not my center line. Where is my center line? My center line is a little bit lower than that. My center line is here, and I'm just totally using my eyeball and kind of counting little crosses. There. So that's at -1, which must be my vertical shift. Phase shift, well, conveniently enough, no wait, first let's do amplitude. Let's see, 1, 2, 3, 4. My amplitude is 4. Phase shift, well, conveniently enough, cosine starts at 0, 1 and does its wiggle like that, kind of like a droopy mustache. And this looks a lot like a droopy mustache too, so I don't have to worry about phase shift. I could, right? I could scoot it over a whole period and I'd never know the difference, but I'm not going to bother if I don't have to. So the only thing is, if the new period is 4 pi, and you get that by taking the original 2 pi and dividing by b, then b must equal 1/2. Okay, now I'm ready. So y equals, my amplitude is 4. I'm supposed to be doing the cosine. My coefficient is 1/2. I don't have a phase shift, so I'm not going to bother factoring it, although I could if I really wanted to. So times x, and the whole thing scooted down 1. Okay. Let's see, a sine function equation. Well, let's get that center line in here. Do, 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 do. Do, do, do. Okay, whoa, yeah, that kind of looks like a center line. So where is that? That center line is at 3, so we must have gotten scooted up 3. And then how far up and down does it wiggle? Oh my. Well, it wiggles this much and that much, and it looks like that's half the way from 3 to 4 or half the way from 3 to 2. So my amplitude is 1/2. My period, well, let's see, if I go from the time it touches the center line until the time it touches the center line again, that would be from there to there. That looks like my period is pi. Okay, it's a sine function. Sine starts at 0, 0, does a little like y equal x thing, a positive slope, and then wiggles from there. And lo and behold, this does something very similar, so I actually do not need to phase shift this one. How lovely. Alright, so originally my period was 2 pi. Now my period is pi. That means that b must equal 2. So I have y equals 1/2 is my amplitude times, let's see, 2, oh my gosh, 1/2 times the sine, sorry, it's a little late, of 2, I don't have a phase shift, so I'm not going to bother to factor here, and then up 3. And there's this fabulous function. Last but not least, we're supposed to do a cosine. First, I'm going to draw in the center line. Looks like it's about there. And that would be at -1. The distance between my center line and my maxima and minima looks like it's 3, so that would be my amplitude, period. Ew, she said. Ew. Okay. Well, let's see. This period is just a little bit past that and that. So if I go from here to here, that's equivalent to that. So it looks like my period is pi long. Okay, pi. Cosine. Normally, cosine looks like a droopy mustache. Starting at 0, 1, it goes bloop, bloop, and then of course it keeps wiggling, but you know. So I have some choices. I could say, I've got a whole bunch of choices. I could say, yep, this used to be over here and it got scooted that much. And then I just have to figure out how much that is. Well, let's see. If this is pi over 2 and pi over 2 is cut into thirds, then each of these must be pi over 6. But then the line I drew is halfway between there, so this has got to be about pi over 12. The space amount, not the actual address. So let's see. 1 pi over 6, 2 pi over 6. Oh, and then a pi over 12. Okay, let me count by 12s. 2 pi over 12, 4 pi over 12, and then one more makes 5 pi over 12. 5 pi over 12. So maybe that's my phase shift. Or I could say, oh, well, actually, maybe I scooted that way. So let's see, what's that? 2 pi over 12, 4 pi over 12, 6 pi over 12, and one more makes 7 pi over 12. Okay, so either of these would totally work. So if I do -5 pi over 12, I would write y equals 3 times the cosine of, oh dear, let's see, if normally the period is 2 pi, and now the period is pi, b must equal 2. I do have a phase shift, so I'm going to go ahead and factor that out. I've got x. Let's see, to scoot to the left 5 pi over 2, I would write plus 5 pi over 2, and all of that is shifted down 1. Here's one answer. Or I could say y is equal to 3 times the cosine of 2 times x, and instead of scooting to the left, I could scoot to the right. I have to scoot a little bit more, so minus 7 pi over 12. Minus 1. Oh no, I'm out of room. Minus 1. Okay. Or maybe I flipped it. Gosh darn. Dragging issues. Okay. Maybe I flipped it. If I flipped it, then I would only have to scoot that way, pi over 12. Okay, so let me do that. Y equals -3 times the cosine of 2 times x, and to scoot to the right, I would write minus pi over 12. Minus 1. And just for giggles, let's prove that all of these, you don't have to have all of these on your homework, but all of these are valid answers. So here I am at desmos.com, and since I want to graph a trig function, I'm going to go ahead and change my x-axis label to be in terms of pi. Well, because my trig function's in radians. I could, I guess, do this in degrees, but I'd rather not. Okay, so the functions I came up with were y equals 3 times the cosine of 2 times x plus 5 pi over 2, oops, minus 1. And I said that y could equal 3 times the cosine of 2 times x minus 7 pi over, well, that's supposed to be over 12, not over 2. 12, there we go. And then that would be minus 1. Oh, look, did you see that? When I minus 1, it lands right on top of there. Okay, so those are the same. And then y equals negative 3 times the cosine of 2 times x minus pi over 12. Oh boy, it's right up there. When I move it down 1, there it is. They're all the same. Yay! Shockingly enough, you're going to complete this worksheet for your homework.